So to recap, this is what we're going to be building, this thing called Conduit, sort of this medium clone. And the way that we're going to be doing this is by using the virtual DOM. The virtual DOM is something that's sort of popularized by React, and it's something that Elm uses as its fundamental way of rendering things. So whereas in JavaScript you can opt into a virtual DOM by using something like React or any of the different virtual DOM systems out there, but in Elm it's the only way to do it. All there is a virtual DOM. That is the fundamental primitive of rendering in Elm. So what do we mean by the DOM? So the DOM is the document object model. This is some HTML. HTML, the hypertext markup language, is a representation of the DOM. It's sort of syntax that describes a particular structure. So here we have an unordered list. It's got a class of languages. It's got two LIs inside of it. One is Elm, the other is JS. This HTML describes this DOM structure. So at the root, we have a root node called, that's a UL. It's got a class attribute of languages. Then it's got two child nodes. One is an LI, another is a different LI. And actually, each of those LIs also has a child node, a text node. So one has a text node called Elm that has Elm in it. The other is a text node that has JS in it. I'm going to be honest with you. For most of my career, I did not know that text nodes existed. I thought they were just magical strings. Turns out they're DOM nodes. I just didn't know that for a long time. So this HTML in the upper left describes this DOM tree on the right that's going to actually exist in the browser's memory. But there are lots of different ways we can represent this DOM tree. We don't have to use HTML to do that. And in fact, Elm doesn't use HTML to do that. Elm just uses plain function calls. So here's how we could represent this in Elm. So we have a function called UL. It's being passed two arguments. The first is a list of attributes. In this case, we have only one attribute, class languages. And then a list of child nodes. So in this case, we have two child nodes. Both of them are LIs. Each of the LIs has a list of attributes, but these don't have any attributes, unlike the UL, so they're just empty lists. And then they also have a list of child nodes. And in this case, both of them have a text node for their child nodes. So Elm just uses plain function calls for all of these. And because Elm uses white space for function application instead of parentheses, we can see that this has a pretty visually similar structure to the underlying the underlying DOM, and also a pretty similar structure to the HTML up here. So Elm doesn't really need a separate templating language for this because we can get something that a little DSL that looks pretty similar just by writing plain Elm code and normal function calls. Fun piece of trivia, this is actually how React was originally designed. Jordan Walk, when he originally made React, he just used it with plain function calls. But at Facebook, they had been doing a lot of PHP templating on the server side. And when he made the first pull requests to introduce it to the company, people were like, this is weird. We want to see our PHP-looking templates. So he actually invented JSX in order to solve that problem and to get his pull request accepted. So he changed it from plain function calls to a template. And that's sort of become the norm in a lot of virtual DOM systems. Whereas Elm, in some sense, goes back to the roots and says, fundamentally, the big idea here is functions. We're just going to use plain function calls to describe this stuff. And that's how our whole code base at work works. That's how all Elm code bases work. Nothing more than plain function calls to describe these things. So the one syntactic note has to do with the positioning of the commas here. So this is not quite idiomatic Elm code. The way that you would idiomatically write this is with the comma on the left here. The first time I saw this, I thought, that looks weird. I'm not going to do it that way. I'm going to do it a different way. Then I sort of realized the benefit of doing it this way, and then I switched and then got used to it and subsequently think, okay, yeah, this way actually is better. So let me explain the problem that this solves. So let's say that I have the comma on the end here. And this is sort of more typically how it looks in JavaScript. The problem is, what happens if I forget that comma? Like if I leave it off, accidentally just left it off. And I've definitely done this before. What is actually happening here? What does this code now do that's different from what it did before? Well, previously, what we had was this is a function call to li passing two arguments, and then this is a function call to li passing two arguments. And they're separated by a comma because there are two elements in the list. But this one doesn't do that anymore. In this one, we're going to get a compile error that says, you are passing 5 arguments to li. And you might be like, no, I'm not. What are you talking about? I'm passing 2 arguments to li twice. But actually, without the comma there, this error accurately represents what's going on. We have li passing 1 argument 2 arguments. There's no comma, so we're just going to keep going. It's just more white space. 3 arguments, 4 arguments, 5 arguments to li. So getting this error message is like kind of confusing because it seems to be just wrong. It seems you're passing all these arguments like, no, I'm not. I look at the code, it looks fine. Especially if you have a particularly long, complicated expression. It can be a really confusing error to get. But if you have, this, instead you have, there we go, I don't know what happened there. Instead we have the comma on the left. Now we have this sort of vertical line, this sort of column of characters that sort of makes it really, really obvious if you leave the comma out. And this works like no matter how many things you add to the list. You can just keep adding to the list and keep adding commas. And if you ever forget one of these commas, it's immediately blindingly obvious that there's something missing there. So I reluctantly tried switching to this style and then realized that, I just never, ever got that error ever again. And I was like, okay, that's worth it. The first time I was pair programming with somebody at work and they got that error and were confused by it, I was like, okay, yeah, we're switching. We're gonna do it this way. And today we have Elm Format, which is a code formatting tool that something like 90% of Elm developers, I think it's actually over 90%. It's really ubiquitously used. It's like Prettier or Go Format or GoFumped, I believe they pronounce it, in other languages, where essentially the idea is to enforce a common syntax across all Elm programs, and it will do it like this. Also worth noting that Elm Format is unique, as far as I know, among front-end code formatters, in that it has no configuration options at all by design. It cannot be configured in any way. And that's a design goal because it prevents style arguments. It means that you can't get into an argument about what you should configure it, about like what should go where, because there just aren't any configuration options. It's pretty nice. So to recap, the things we talked about in part 1. First we talked about compiling, so running elm make, passing main.elm, which is our source file, and then output of elm.js, which is the .js file that we're ultimately going to give to the browser using a script tag in index.html. Talked about functions and how to define them, and also how to call them. So when we call them, passing, for example, pluralized leaf, leaves, and one, we don't use commas and we don't use parentheses. If we do use parentheses, it's only to disambiguate between nested expressions, not because function calling actually needs any parentheses. Talked about if expressions, so if quantity double equals 1, then. Talked about how in Elm use double equals instead of triple equals. We have then instead of curly braces. Else is required because if is an expression. So you can sort of pick it up and move it in different places, assign the result to a value, just like a JavaScript ternary. And finally, we talked about the virtual DOM and how in Elm, virtual DOM is done using plain function calls. So li passing a list of attributes and then also a list of child nodes. We also talked about how text nodes in Elm are represented by a function called text.